4.3 Properties of Logarithms, Day 2. In this lesson, you will be able to use the product, quotient, and power rule to condense logarithmic expressions. So now in this section, we're going to be condensing. That means that we are taking an expanded logarithm and now we are condensing. So if you notice on the product rule, it has been expanded with addition. When you condense, you will multiply the two terms and then simplify if you can. For the quotient rule, they have expanded with subtraction. We are condensing with division, so you will divide the terms. And then for the power rule, if there is a number in front, it now becomes your power or your exponent. So power rule basically is taking the number in front and making it the exponent. In example 1, we're going to condense each logarithmic expression using our properties. So let's start with A. So you notice they are adding, so we're going to use the product with property, which means these two terms, 2 and 32, we're going to actually multiply them together and get 64. And then we have to simplify this. So this means 4 to the what power is 64, which is 3. B. Notice with my two terms, they have expanded them with subtraction. So we are going to divide. So you're going to have log, and the first term goes on the top, and the second term goes on the bottom. And that's as far as you can go. Notice when you condense, you only have one log or natural log. Okay, in example C, notice this 1/2 now has to become the exponent, because that is the power property. And this 4 has to become the exponent. So you take care of those first. Then what you do is condense the two terms. Well, first of all, we know that raising something to the 1/2 means square root of x. So just remember that. So we're going to condense again with multiplication. So we have log square root of x times x minus 1 to the 4th power, and we leave it like this. And then D, the 3 goes as the power. You always do the powers first. Then I'm going to condense these two terms using division, because that's the quotient property. The top term, or the first term, goes in the numerator, and the second term goes in the denominator. Okay, example 1 is continued with letter E. If you notice, each of my terms has a power. So I'm going to use the power property and make those exponents. So the 4, the 2, and the 1/2 become powers. And so I have log bx to the 4th. And since this says minus, that means that we have to use the quotient property. So the 6 squared goes on the bottom, and the y to the 1/2 goes on the bottom. And so if we were to simplify this, this would be x to the 4th. 6 squared is 36. And then the y to the 1/2 is the square root of y. And that's your simplified answer. For F, I'm going to take care of the inside first. Actually, this 1/3 is going to be a power for each term. So I'm going to do that first. So this is to the 1/3 power. The x is to the 1/3. And the x squared minus 25 is to the 1/3. And then same like for letter E. I have two subtractions, so I have to use the quotient property. Now the 5 is also a power, so I'm going to have to put that as an exponent, but there's a 1/3 there, so that's going to become 5/3. So when you write your final answer, you're going to have ln x plus 6 to the 5/3. I have an x to the 1/3 is the same thing as the cube root of x times x squared minus 25 to the 1/3. Or you can put them both under the cube root, or you can leave it like this. Because another way you can write it is ln. We can do a big cube root. X plus 6 has the 5th power. And then I have x times x squared minus 25. So this answer is more acceptable because everything is under one cube root. And then G, I don't have any powers. I don't have to use a power property. There's a plus here, so I'm going to use the product property for these two terms to condense. And there's a minus and a minus, so both of those terms go in your denominator. If you wanted to go further and simplify, you can factor the top, because that's a difference of squares, 2. That way those two terms cancel, and your simplified answer will be as follows. So either those are acceptable for your final answer for G.